Hello students, let us discuss the characteristic properties of D-block elements. As we have already discussed some of the characteristic properties of transition elements, that is variable oxidation state, magnetic properties and colored complexes. So in this video, we are going to discuss the characteristic properties like formation of interstitial compounds, alloy formation and the catalytic behavior and also the formation of complex ions. So let us discuss these characteristic properties one by one. First, catalytic properties. As you are already familiar with the word catalyst, what is catalyst? A catalyst is a substance that speeds up the reaction by providing an alternative reaction route with lower activation energy. So, we have come across the various type of catalyst in the different chemical reactions. So, usually, they are the transition metals. So, the transition metals are very good catalyst because of the two reasons. First reason, they show variable oxidation states. Because of this, allow them to act as intermediates in the exchange of electron between the reacting species. So the most important point is because of they are showing a variable oxidation state, they act as a good catalyst. They provide a surface for the reaction to occur. The metal forms weak bond to the reacting species, holding them in place. Here it provides a greater surface area for the reaction to occur. Because of these two reasons, we can say that transition metal act as a catalyst. There are different examples of catalyst in the different reactions, like metals like nickel and platinum used in the hydrogenation reactions. These are the very common catalyst and these are the transition metal. As we are familiar with the Haber process, in that iron act as a catalyst, which is a transition metal. Similarly, in the catalytic converters, PD and RH are the catalyst. And in the contact process, V2O5, that is a oxide of vanadium, is acting as a catalyst. So there are number of examples where the catalysts are nothing but the transition metals. As we know that finely divided catalysts are increases the reaction more because it will be increases the surface area. This will increases the surface area. The finely division make the increase in the surface area of catalyst. So that will provide more collision sites. So it is better to use the catalyst in the finely divided powders as we have discussed in the surface chemistry. Next property, that is formation of complex compounds. Metal ions bind a number of anions or the neutral molecules giving the complex. As we have already come across the complexes in different equation where there is a transition metal that is at the act as the central metal ion and in which there will be a anions or the neutral molecules which are binding with it. So when you take the example of FeH2O6 3 positive which have an octahedral geometry, in this you can see that the Fe ion act as a central metal which is binded by a number of anions or neutral molecules. Like this, in this there is a number of water molecule, that is it get binded to the central metal ion. So here the formation of a complex compound is one of the important characteristic property of a transition metal. So these can form the complexes as it is shown in the different example. In these examples you can see that the central metal ion is nothing but the transition metal ion. This is due to the comparatively smaller size of metal ions due to high ionic charges and due to the availability of d orbitals for the bond formation, as here the available vacant d orbitals are necessary for the bond formation. So that is available in the case of transition metal ions. So what we can say that the formation of complex compounds by the transition metal ion is due to the comparatively smaller size of metal ion because of their high ionic charges and because of the vacant d orbitals available, that is the availability of d orbitals for the bond formation. So that will be going to discuss more in detail in the next chapter, that is in the coordination compounds. Next property, that is formation of interstitial compounds. Transition elements form a large number of interstitial compounds in which the small atoms such as hydrogen, carbon, boron and nitrogen occupy the empty spaces in their lattice. As shown in the figure here, there are some empty spaces in the lattice, in their lattice, where the small molecules like carbon, like boron, etc. can occupy these spaces. So because of this reason, we can say that it forms a compound by occupying the smaller atoms. So the interstitial compounds are those compounds which are formed when the small atoms like carbon, hydrogen and nitrogen are trapped inside the crystal lattice of the metals. So such type of compounds are called as what? Interstitial compounds. Like when you take the example of here VH 0.56, TiH 1.7. So in these all cases, here in the case of VH 0.56, that is in the case of crystal of vanadium, the small amount of hydrogen is trapped in the interstitial site. So that is resulting in this formation because their ratio is not fixed here. That's why it is a non-stoichiometric compounds. So they are usually non-stoichiometric and are neither triplic ionic or nor covalent. That is not, it is neither ionic nor covalent, but we can call it as it is non-stoichiometric, as we have discussed in the solid state. That is, here the ratio is not fixed. So the examples are given here. There are different examples of the interstitial compounds which is formed by the transition metal elements. So the principal physical and chemical characteristic of these compounds are as follow. That is, the characteristic features of these compounds, that is interstitial compounds, are given. They have high melting point, higher than those of pure metal. So when you compare the melting point of these compound, it will be higher than those of metal. Next, they are very hard and some are approaching the hardness in compared to that of diamond. That means it is extremely hard. They retain metallic conductivity and they are chemically inert. So these are the characteristic features of interstitial compounds. Next property, that is alloy formation. Alloys are the mixture of metals to improve the strength. In our day-to-day life, we have come across a various type of alloys, that is bronze, even the steel. So these are actually the mixture of metals, that is in order to improve its properties. So we are mixing the different metals to form alloys. Formation of alloy, the D block elements have almost similar atomic sizes. Therefore, these elements can mutually substitute their position in their crystal lattice. In this way, many alloys are possible between the transition metals. So because of the almost similar sizes, as we have discussed in the atomic radii concept, they have a quite similar atomic radiuses, because they can easily substitute mutually, they can substitute their position in the crystal lattice. So this is resulting in the formation of alloys. It can be better explained through this diagram. So in this diagram you can see the crystal lattice in which the two different colors are shown, that is the metal, atoms of metal M and the atoms of metal M dash. That is a black color circle, that is actually the atoms of metal M dash. That means two different metals and they are almost equal in the size. You can see almost they are equal in the size. So they are mutually substituting their position in the crystal lattice. That means in the crystal lattice you can see both the metals. So because it is possible because of their almost similar sizes. So therefore these elements can mutually substitute their position in the crystal lattice. It results in the formation of alloys. So the alloy formation is because of the similar atomic radii and other characteristics of transition metal. The alloys so formed are hard and often high melting point, like chromium, vanadium, tungsten, molybdenum, manganese are used for the production of varieties of steels and stainless steels. So we are familiar with the stainless steels which we are using at home. So that is made up of the variety of transition metals which is shown here, and the alloys of transition metals with non-transition metals such as brass, bronze are also formed. That is, in this example, brass is made up of copper and zinc. So here the zinc and copper both are the transition metals, and in the case of bronze, copper and tin. So these are the alloys which is formed from the transition metals. So in this video we discussed about the important properties, that is the characteristic features of a D block element. So this is all about this video. Have a nice day.